Hello everyone. Today in this video, let us continue with the Theorem 1.2 from the same chapter as we are doing real numbers from Grade 10 NCERT book. The Theorem 1.2 states that, this is also called as Fundamental Theorem of Arithmetic. It states that every composite number can be expressed or factorized. You can say anything. As a product of primes, it can express every composite number as a product of primes. And this factorization is unique as part of the order, apart from the order which the prime factors occur. So here, to understand this theorem carefully, let us see all the natural numbers. The natural number starts from 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. These are all called natural numbers, right? So all these natural numbers are either prime or composite, right? Either prime or composite except one. One is neither prime nor composite. The remaining all numbers are either prime or composite. What are prime? Let us recall. What are prime numbers? The numbers which have exactly two factors. The numbers which have exactly two factors, namely 1 and itself. They are called prime numbers. And the other numbers which are having more than two factors, like other than 1 and itself, they have remaining extra also, they are called composite numbers. Here the prime numbers, as you know, 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, and so on. So 2, 3, 5, 7, they are called prime because they have only 1 and themselves as a factor, only two factors. The remaining numbers like 4, 6, 8, 9, 10, these type of numbers are called composite numbers. If you try to observe, these composite numbers can be expressed, composite numbers I'll take. These composite numbers can be taken and expressed in the form of product of primes. Let us check. 4 can be written as 2 into 2, and 6 is a prime composite number. 6 can be written as like 2 into 3, and you can take 8 as like 2 into 2 into 2. So observe what are the factors we are taking. They are all prime numbers. And similarly 9 I can write as like 3 into 3, and 10 I can write as like 2 into 5. So every composite number you try to understand, every composite number can be expressed in the form of product of primes. If sometimes you are having same prime number, you can express it as a product of primes, like powers of primes. So you can write it as 2 cubed. You can write this as 2 squared. This can be written as 3 squared, and so on. So this type of all the natural numbers can be expressed as a powers of product of primes. Powers also, if you have more than one same factor repeating, you can write it as powers also. So right, so only these are the simple numbers. Let us take a little bit bigger number. So let us try with 1092. This 1092 can be, let us write in the form of a factor tree method. So 1092, when we divide with the 2, because 2 is a prime number, when we divide with the 2, we will get 546 as a quotient. So 2 into 546 is 1092. So here 2 is a prime number. As prime number comes, circle them immediately. Now 546. Let us divide 546. 546 can be written as 3 times 182. 3 is a prime number. That's why I circled. And divide 182 with again 2 table. 2 times 91 is 182. Right? Similarly, 91 you can divide still. Don't write 9 nines. 9 nines are, 9 is not a prime number. So we are using always prime numbers. Remember that while doing the factorization. So 91 goes in 7 table. 7 times 13. 13 is also a prime number. We can stop. So as we get all the prime numbers, we can stop it. Now we can write this 1092 as 2 times 3 times 2 times, I'm writing all the circled prime numbers, 7 times 13. So this is the prime factorization of 1092, which can be also written as 2 square. 2 is repeated 2 times. So 2 square times 3 times 7 times 13. So this is the prime factorization of 1092. So this is the unique way of writing into prime factors. That means everybody in what way they may factorize, finally they'll get the same factors, same prime factors, but maybe the order of the factors may be different. They may change according to depending upon the divisors they take every time. For example, let somebody may write like this, like they'll write 1092 as like 7 times, 13 times, depending upon the factors they take in the beginning first. Sometimes they'll get 7 table first, they'll get 7 first, like that. And some may write like 1092 as like 13 times. They may take first only 13 table, 13 times, 7 times, 3 times, 2 times 2. So whatever factors they may take first or second, the order may be not different, but the number of the factors will be the same. The factors won't change. So if we prefer everybody to write as the factors in the increasing order, like 1092 as 2 times 2 times increasing order, 3 times, 7 times, and finally 13. So if we can write like increasing order, then there will be only one way of representing the composite numbers by the product of primes. Right? So the fact comes now. The fact is, now come to the theorem 1.2. Now you read once again the statement. Every composite number can be expressed as a product of primes, and this factorization is unique. This factorization is unique apart from the order in which the prime factors may occur. So the prime factorization of natural numbers is unique. So you can say that the prime factorization of natural numbers are all unique except for the order of the factors.